Welcome to the Explainer. Today we're digging into a whole new playbook for STEM education, one that's designed to tackle the single biggest roadblock to learning. And trust me, the answer's probably not what you think.
Okay, so let's just dive right in with a question. What do you think is the biggest, most damaging thing for learning in a classroom? I mean, your first thought might be something like stress or maybe not getting enough sleep, even really serious stuff like depression. But what if I told you it's something way more common, something every single one of us has felt?
Yep, it's boredom. Just plain boredom. And this isn't just a hunch, it's backed by a ton of research. You know that feeling, right? When you're totally checked out, your mind is a million miles away because you're just not hooked. Well, it turns out that state isn't just harmless daydreaming. It's actually super destructive to the whole learning process.
So, to put some numbers on this, boredom has this really powerful negative effect on learning, a negative effect size of minus 0.49. Now, effect size is just a fancy term for measuring how strong that impact is. And get this, negative 0.49 is a bigger hit to learning than moving schools or even depression and sleep deprivation. I mean, wow! It's like this silent killer of potential hiding in plain sight in our schools.
And that really leads us to the heart of the problem, right? The traditional classroom, the one most of us probably remember, can actually create the very boredom that shuts down learning. So it's really time to take a hard look at that old rulebook and ask, is this actually working anymore?
And here's a huge piece of the puzzle. In a lot of classrooms, there's this unspoken culture of fear. Kids are just terrified of looking dumb. They're afraid to ask questions, afraid to admit they don't know something. But think about it. Admitting you don't know is the first step to actually learning anything. It's where it all begins.
And this right here, this just nails it. Traditional teaching often shows you what was discovered. You know, here's the formula, here's the answer. But it almost never lets you struggle with how to discover it for yourself. When you're just following a recipe in a lab, a cookbook experiment where you already know the outcome, you might learn a fact, but you never ever get to practice the real, messy, and yes, sometimes frustrating process of real discovery.
So this old way of doing things, it's not without its consequences. It's actually leading to a crisis of curiosity. That natural drive kids have to ask why, well, it gets systematically trained right out of them. And we absolutely have to fix that if we want to build a generation of real thinkers.
So what's the opposite of boredom? What's the cure? It's this state of energized focus, what some people call being in the zone, or what psychologists call flow. You know that feeling when you're so absorbed in something that time just flies by? That's it. So fighting boredom isn't just about making class fun. It's about creating the conditions for that kind of deep, meaningful engagement. Okay, and seeing it laid out like this on a chart is pretty eye-opening. Just look at that bar for boredom on the far left. It's a bigger roadblock to learning than things we normally think of as way more serious. This just completely reframes how absolutely critical it is to keep students engaged, doesn't it?
All right, so if the old playbook is broken, what do we replace it with? Let's get into the solution. A new playbook for learning that totally flips the script on the roles of the teacher and the student.
And this is the big philosophical shift right here. We're moving away from the teacher as the sage on the stage, the all-knowing expert at the front of the room, and toward the teacher as the guide on the side, someone who's more of a coach, a facilitator, who helps students find their own way. The whole point of this new playbook is to create what you'd call an intellectually safe space. A classroom where it's okay to make mistakes. In fact, it's not just okay, it's seen as a totally essential part of learning. It's a place where curiosity can actually breathe without being afraid of being wrong.
And this means making learning feel more like play. But, and this is a big but, there is a trap here. You can't just take a boring task and slap a game on top of it. Some people call this chocolate-covered broccoli. Trust me, kids see right through that. The play has to feel real. It has to be part of the learning itself, not just a sugary coating.
Okay, so this all sounds great in theory, but how do you actually do it? How do we put this new playbook into action? Well, it's not just a bunch of ideas. There are real, practical tools that teachers can start using right now. Let's look at a few.
Here's one that's just so simple and brilliant. The question parking lot. It's literally just a spot on the wall where students can stick a sticky note with a question anytime it pops into their head. This does two things. It validates their curiosity, showing them their questions matter, and it does it without completely derailing the lesson. Genius.
Or how about this low-tech exercise? You ask your students to write out, step by step, how to make a peanut butter and jelly sandwich. Then you, the teacher, follow their instructions exactly as written. So when the first step is put peanut butter on bread, you take the entire closed jar and place it on top of the sealed bag of bread. Instantly, they get it. They see how incredibly important it is to be precise. It's such a fun way to teach the basics of algorithmic thinking, creating a clear set of rules to get something done.
And this whole idea of focusing on the how instead of just the what isn't just for fun things like sandwiches. It actually gives us a really powerful way to handle topics that can be, a little controversial, like evolution or climate change. It allows you to approach them in a scientific, evidence-based way.
The trick is to shift the conversation away from belief and toward evidence. So instead of asking a loaded question like, "Do you believe the Earth is billions of years old?" you reframe it. You ask, "What kind of evidence would we need to collect to figure out the age of the Earth?" See what that does? It immediately puts everyone on the same team, the team of scientific investigators.
So when you step back and look at all this, it becomes clear that this isn't just about making school a little more fun. This new playbook, these tools, they represent a massive shift in what we're actually preparing students for. We have to get them ready for a future that is, frankly, impossible to predict.
And of course, the biggest driver of that unpredictable future is AI. Just look at this prediction from one entrepreneur. He's guessing that in 10 years, AI might take 9 out of 10 engineering jobs. Now, whether that exact number is right or not, the point is the ground is shifting under our feet. The skills that got us here won't be the skills we need for tomorrow. And that forces us to ask a really, really important question. In a world increasingly powered by AI, what kind of thinkers are actually going to succeed? If a machine can do the technical stuff, what's left for us humans to do? Well, the answer lies in all the stuff that AI can't do. It's about building that can-try spirit, fostering resilience so you don't give up when you fail. It's about practicing how to solve real, messy problems that don't have an answer in the back of the book. It's about encouraging unique, creative thinking and learning how to fail in a safe space. These are the human skills. And this, right here, is really the bottom line. A traditional, teacher-centered classroom is great at preparing students for situations where there's always going to be someone there to tell them exactly what to do. But that world is fading fast. We need to be preparing them for a world where they're going to have to figure things out on their own. Which brings us to one last thought to leave you with. If the whole point of school isn't just to memorize stuff, but to actually learn how to think, are we really teaching the right way? Are our classrooms truly designed to build the innovators and problem solvers of tomorrow? Or are we just teaching them to be really good at following instructions for a world that doesn't really exist anymore?